In the future, when we're designing robots, touch might be a very important feature to add for manipulation of stuff accurately. Now, the human body has about, in its most sensitive areas, 100 to 10 receptors per cubic centimeter if you look up online in various sources. And looking at the hand, they say adult human hand has about 448 square centimeters. So that is, on the hand alone, for a robot hand, 44,800 to 4,480 if you take a very low, only 10 receptors, which is per cubic centimeter, which is like the least sensitive parts of the body. Not only do you have all these receptors on the human body working together, these receptors are more complex because we also have them in they can sense different amount of pressures, they can sense rubbing, some of them are more sensitive to vibration, some of them are sensitive to heat, there's pain, there's chemical receptors. So you could have, at least you have pain, 1, pressure, 2, movement, some movement ones, 3, heat, heat 4, cold is a separate one, 5, it's 6. So you might want to even make more for the different types of things. You might want to decrease the resolution for that. And some of them can be more important. This pressure is probably the most important one. You could have ones for chemical sensors. But this is a lot of things for a robot to handle and to learn. Now, I think there is some pros and cons for a robot learning this compared to learning, let's say, vision or something for machine learning and stuff like that. The reason why I think there might be some pros and cons with it is vision is something that happens a lot faster, I think. So you have less time to process. By vision, I mean being a lot faster is when you're holding something, gripping something slowly, or gripping something and moving your fingers around, to some extent, stuff is more predictable how it changes. If you're sliding your fingers along something, you can predict how it's going to change more from second to second. When if you're looking at something in distance and how it's moving, it can be much more erratic and unpredictable. So you have to compute much faster. So you have that computation part with that. We have already cameras that have much more pixels per area than 100 to 10 per square centimeter. In some cases. So that can be more data, not always. Touch is a lot less context dependent. We don't have as much language and words and stuff like that. Touch is not dependent on lighting conditions as much, or other conditions like that. It is dependent on pressure and stuff like that, but that's something you much more easily can calculate. So we have that advantage with touch not being the worst thing out there. We also have the thing that it's easier to model touch on the computer, making simulated environments. That is a much easier thing. On the other hand, touch is a much more difficult problem because touch is with virtual reality we can mimic very well with the best devices seeing stuff. That is a great thing we can do. However, on the other hand, we're not that good at mimicking touch sensations, and we might get better. We might make, say, changing gloves that have little things that can apply different pressures by expanding and contracting in different places, or having little bubbles that blow up or not blow up locally, or socking different parts of your skin locally, and we can combine all that. Then we can wrap them around tightly so that you feel better. But probably it's not going to be the exact same sensation by far, even though if you train a lot with it, you might learn to parallels better. Like if you see more screens that are 3D, we can figure out kind of 3D dimensions based on clues and translations. If you were to take a visual example of all this. So we do have all those problems. But I think it's a very important part because there is stuff you just can't get from sight. And that includes this feedback of, and also you can't always just illuminate stuff. Ways we could lower this problem is that our body sometimes doesn't compress the touch sensation before it reaches our brains. We take several signals from all over the place and kind of combine them into a reduced signal which loses some data. So you could do that. Another problem with touch being incorporated into robots is that it is much less local, it's more spread out, which means much more complex wiring and stuff. Better handling microelectronics would really handle this. Could maybe solve a lot of this. But another problem with touch is that producing materials that are durable and strong enough and can be also safe and molded flexibly. With a camera, you can put it under some heavy lenses, sealed or far away. Touch, you have to have an actual hand and device touching the stuff. Now, we can get rid of some of that by putting sensors that sense vibrations and stuff, even through a thick piece of metal or force and stuff. But we do lose a lot of sensitivity, but we can regain some of it also using active transmissions of vibrations through material like echolocation. But that also becomes more complicated in some ways. Sometimes it can make simple, but sometimes more complicated. It also means you have to make vibrations go through material. This might not always be desirable in all circumstances. Another thing about this whole thing that may or may not be the most desirable thing is we also have to understand that the materials, if we want to really expand this, materials act more differently for touch under different circumstances than light does or camera does. When something is cold, something might be less flexible, and that includes your sensor sensitivity might change for press and stuff, and how sound is transmitted much more with temperature dependent or pressure dependent. So you have all those feedbacks more. We also don't have the same amount of data sets for touch that we have for like visual stuff with online images and stuff. In some ways we could make those data sets much more easily because we have the ability with machine learning and stuff right now. So yeah, that's just some thoughts about touch all over the place. One idea maybe also will be to use cameras. Besides the ways now we could do this, is there's microelectronics for a variety of ways of sensing temperatures from metals change the resistivity, or can even make small electric currents depending on the temperature differences, and it's very similar to when you have two metals that have two different properties of conductivity. At the intersection, they do it more, where they fuse together for a variety of complex and sometimes simple reasons. One is that at those intersections, because the metals mismatch, electricity flows more easily than heat, so some of the heat energy makes the electricity flow through the metals, because it needs to transmit the heat energy somehow, and sometimes it's easier to do it through electricity. That is one very oversimplified one, or sometimes heat can be sometimes moves different parts of a metal differently. The electrons, the holes, which are where the electron isn't, so it kind of has like a positive charge opposite electron, because electron just isn't there, so it fills up, empty space fills up like a false positive charge. Or the atoms and everything just move differently, and that can cause different, if they move differently in different materials, one material can accumulate charge and start an electrical thing going on. Other ways you can do it is with touch, is that different, if you put two electrodes close and close together, electricity jumps more easily between them. So if you have a material designed, you can make it so particles that are conductive get closer and closer together with pressure, and that can be used to sense various forms of touch. Another way that you can sense touch in various forms is something called a piezoelectric effect, where you have in a crystal different amounts of positive and negative charges, something like acts like that, and when you pressure it, the positive and negative charges move farther or closer apart, causing electricity energy to build up and be released. You can also just simply vibrate the whole device, and the vibrations that travel through the whole device can cause how would we say it? The vibrations that travel through the device then can hit the object, and depending on how they hit the object, they travel differently. Because like some materials absorb it more, some materials will bend it away more, some materials will vibrate different frequencies, and you can use that kind of like an acoustic way to like acoustically map it. In some ways, it can map deep in the material, but can't map the surface as precisely. Even though there's tricks around that way to try to make it go more along the surface, but that all requires you to vibrate the material, which might not always be the most desirable. You can also rub the material to get some more sensitive information by seeing how rubbing changes the pressure and stuff, and gives you that feedback, and people do that themselves, which is very different than the vibration, but it's also a little bit similar. For chemical ones, you can have stuff, there's a bunch of materials that change their conductivity based on chemicals, because chemicals can cause material to locally swell or not, which can bring electrical things closer or farther apart, causing it to change resistivity. It can also alter the surface of the material in different ways, which can alter how electrons travel across the surface. If it's a material with a bunch of ions and it's absorbed by material, different ions can permeate different materials differently, and ions can carry electrical charge, so that can do it. You can also have material that sticks to different compounds differently, and that stickiness can be used to sense whether, if you attach that to a touch sensor, how much it sticks to it can, or moves with it on the surface, can give you some feedback there about the chemicals, and that can, and we do sense chemicals on our skin, such as skin irritants. And that can be with pain and everything. You can have pain receptors, so-called, just to see more deep tissue damage within a material. But this is all really fancy stuff to some extent, and you would have to probably really customize and tailor it for many things, and you might need a fancy 3D printer or something for it. And you also have to think about the environmental conditions, because a lot of these sensors make your material weaker chemically or something. Another idea is that you have some materials that change colors when they are exposed to stressed out or compressed or much more. So you could have those color changing materials and send a light and have a little camera and looks at through that light and camera along the surface. Now you don't necessarily have to sign it looking at it from the outside, which it could help, like looking at your hand to see touch and pointing. You could use light that penetrates one material, like an infrared light, to see the stuff underneath it. You could do this with instead that the light's inside and seems closer inside, so it's all internal. You could do some combinations. You could sign it through and it comes back. To protect the sensors, again, something you could do is you could protect the sensors using thin coatings or something, or have removable hands for different jobs with different durabilities but less sensitivity to switch out parts in your robot or whatever device you're doing. Another possibility is instead doing the same things with magnets with changing magnetic properties locally. Besides light and everything, you could also send electrical currents through something that's not as sophisticated, but send out complex electrical current that would do vary in place and location, and have like a temporal aspect, and have complex waves that appear, and that can actually help tell you where it's located if you switch it on and off faster, but those become more sensitive to magnets and external electrical fields. So you might need some shielding and stuff, or only use them in special case scenarios where you can ignore that effect. There's a thing called electron impedance microscopy, and spectroscopy. It's the only spectroscopy that we does not use light in. But if you vary electrical current just right through a material, you can actually start measuring different layers' resistivities and make like a circuit diagram, like this layer is more resistive, this layer has higher capacitance and stuff like that, without actually using multiple electrodes or many electrodes, by just varying electrical current. And you could do something similar in one of these devices. Probably in the future, it's going to be a combination of a bunch of different technologies to do it. But we already have like light devices, but we have less different raw types of sensors for light. And I'm thinking for like ones, and a less a case by case basis. Now, yes, there's a ton of different cameras, but the camera technology is more like how much do you want to spend the money on lenses or optics? That's more important. Or how much money do you want to spend on the light source for it? Or and then the actual sensors more the same on how much money you want to spend on taking the same sensor technology, upgrading it in this or that way, but the same basic more underlying technology. And I really do see this is going to be much more of a wide range of different technologies that are going to be used when building this whole entire thing. Now, I could be wrong and one technology wins over, but I really doubt it because A, we're kind of late to the game building these devices, so we have less of a set track record and we have more options now. Now when we have all these people that could be entering the market competing. And B, even like light sensing technology is more diverging and branching out than it used to. It kind of got branched out for a while, then consolidated. Now it's branching out again with easier manufacturing techniques and more different types of manufacturing. So yeah, I think even light technology is going more the branching route. And then when we have this, I've not discussed other things that fancy robots will have, and I think touch is the most important. That's not sight. And hearing, I think we've already developed well, but I haven't even touched smell, for example. Well, thank you very much for listening. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard. With your help, I think I can do it. Again, thank you very much. Goodbye.